Okay, now let's start today's problem solving. This problem is selected from Iran team selection test in 2001, which is placed in problem 1. So, in the acute triangle ABC, angle B is greater than angle C, and let M be the midpoint of BE, and let E and F be the feet of the altitudes from B and C. Then we know the two angles are right angles, right? So we can have the 4 points B, C, E, F concyclic. And then since M is the midpoint of BC, then we can easily know that M is the center of the circumcircle of the quadrilateral, cyclic quadrilateral. So let's continue. Let K and L be the midpoints of ME and MF respectively. Then T, B and point be a point on line KL such that TA is parallel to BC, and we have to prove that TA is equals to TM. So before this, we have to know one little conclusion. So we have to prove one lemma. Let's look at this graph. The things are the same in the question, and we have ME, MF, and line L, and L is parallel to BC. That means here the line L is equivalent to AT in the picture, in the diagram above. We have to prove that the three lines ME, MF, and L are all tangent to the circle omega, which refers to the circle AEF. First, we can easily know that the line L is parallel to BC, and it is tangent to the circle omega, right? Because H is the intersection of BE and CF, the altitudes of the of the triangle ABC. Then H is the orthocenter of the triangle ABC. Then we can easily have H lies on the circle omega, right? And AH is the diameter. And we can easily know that AH is perpendicular to BC. Then it is perpendicular to L. Then we have L is tangent to omega. And then how can we prove that ME and MF are tangent to omega? We just need to prove one of these. So we try to find this angle. Let me just take it as one line, and it is perpendicular, and we find the center of this circle, and we connect, maybe we denote it as O, and we connect OF. We try to prove that the angle OFM equals to 90 degrees. What does it mean? It means this angle MFC equals to angle OFA. Why do I say this? That is because AFC is a right angle. And what is the angle OFA equal to? That is OAF. And angle MFC equals to angle MCF. And do these two angles equal? The answer is yes. Why? Because here it is the point D, we can easily show that ACDF are concyclic. Then we have the two angles FAH equals to FCM, and then we have MF is tangent to the circle omega, and then in the same way, we can prove that ME is tangent to the circle omega. So we have proved that the three lines are all tangent to omega. So if according to the lemma, we call it lemma. So from here we can draw the circumcircle of the triangle AEF. Okay, so actually this point lies on the circle AEF. And then what can we do? We know that MF, ME, AT all tangent omega. Let me denote this triangle as omega. This circle as omega. Let me write it better. So what can we have? We know that the power, notice this point K, power of K to omega equals to KE squared, right? And equals to KM squared, because E is the midpoint of EM, K is the midpoint of EM, and equals to, now this is the point. If we let me write it first. Maybe we call it what does gamma stand for? The gamma means where a circle centered M with radius 0. So here the point is, if we have one point, what can it be equivalent to? It can be seen as one circle. Remember, this is the most important here. A point can be seen as a circle with radius 0. And then we know that K lies the radical axis of omega and gamma. Let me just copy these words. Why? Because in the same way, we have the point L, right? In the same way, L lies on the radical axis of omega and gamma. So what can we infer from this? That is, KL is the radical axis of omega and gamma, plus T is on KL. What does it mean? T is on the radical axis of the two circles. So T is on KL And that means power of T2 omega equals to power of T2 gamma. And that means T a square equals to Tm square. Why Ta square is the power of T2 omega? That is because we have proved it before. Ta is tangent to omega. So then we have Ta square is the power of T2 omega, right? And then we have Ta equals to Tm. So we have proved this problem, right? We just need a lemma. Make sure we just need a lemma. It is which is proper to be used, and we have to find a key to the problem. Then we can find the solution. So that's the end of the problem. Thank you for watching.